Hi, my name is Yihui Yang from TU Munich. In this video, I'm going to present our recent work on 40-point cloud registration. We are living in a world full of changes, and the geometric changes around us can be captured by modern measurement technologies like laser scanning. These surface changes can be further detected and quantified by comparing this generated point cloud time series, which we call 40-point clouds. These 40-point clouds must be unified into a coordinate system before change detection or deformation analysis. So now a question arises: how can we precisely align these unregistered 40-point clouds? In the context of geodetic monitoring, we can capture the surface changes by fixing a laser scanner and scanning an object with a high frequency. This so-called permanent laser scanning system can derive high spatial and temporal resolution data so that we can find the detailed deformation processes on the object surfaces, for example in this landslide. Of course, the prerequisite is a reliable and accurate registration of these point clouds. So typically we can select the first epoch as a reference and compute the transformations of the subsequent scans to this reference scan. And then we can further georeference all scans to a geodetic data. However, if there are not sufficient stable targets, the registration only based on point clouds may fail when a large area undergoes changes or deformations. Therefore, we need to develop a robust 40-point cloud registration method that should be target-free and also should be fast when registering, for example, thousands of scans. To address these challenges, we propose a new fine registration method that is called Piecewise-ICP. It is target-free and learning-free and doesn't need time-consuming feature detection or matching. Specifically, we use adaptive strategy to determine the registration pair sequence. And then we perform a robust and efficient pairwise registration using small planar pitches and piecewise distance thresholds, which can automatically identify the stable areas in deformed point clouds. And finally, we introduce a Kalman field to refine this estimated transformation sequence. To evaluate the registration performance, we applied our workflow on a real 40-point cloud dataset from a permanent laser scanning system for this landslide monitoring. The experimental results showed that our method could achieve millimeters level registration accuracy, which is better than the existing robust ICP variants and even the target-based strategy. And the pairwise registration in this dataset only takes around 2 minutes. For more details about our work, please read our paper published in the ISPRS journal, and also our code and some of the data are open sourced on GitHub. So thank you for listening.